Okay, Part A for 2007 Form B begins with knowing e to the x. And we're going to write the first few terms of e to the x. Actually, I'm going to put straight equal signs because I'm going to do plus dot, 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 and general term. Make sure you have this formula memorized. And then we are being asked to find 6 times e to the negative x cubed. So first, e to the negative x cubed. Hold on. X divided by 3. Never mind. So substituting that in, I get 1, and then substituting x over 3. Substituting this into the squared and simplifying while I'm at it. The negative sign squared becomes positive. The divided by 3 squared goes in the denominator with the 3 factorial. And then when I plug, oh, hold on, I looked at the wrong one. We're at 2 factorial. Then plugging it in here, the negative will stick, and then the 3 to the third power will show up in the denominator right next to the 3 factorial. And then when I put it in the formula, the negative of negative x over 3 will show up as negative 1 to the n. The divided by 3 will show up as divided by 3 to the n, and then I still have that n factorial. Then when I multiply by 6, it's just going to multiply across the board. And there we go. They asked for, let me make sure, for A, first 4 non-zero terms and the general term. I have 1, 2, 3, 4, and the general term, good to go. Part B. Part B, I'm going to take what I have there, but I'm going to think of it as having t values as I integrate from 0 to x. However, if you realize what you're doing and you see that this is the center, you know that basically you're just integrating without having to put a plus c. For the sake of making sure you're clear, I'm going to go through the integration process just to clarify. So I'm integrating from 0 to x, 6 minus, and this will give me a chance to also simplify. 6 divided by 3, but use t instead of x. And simplifying 6 divided by 2 gives me 3, and then the 3 squared. So I end up with t squared over 3. And then for t cubed, looking right here, I have these will cancel, leaving me with 1/9. And then for the rest of this, I could simplify it a touch, but I don't think it's really worth it. So I'm going to leave it as t to the n. Okay, so integrating this, because the center is 0, I can just multiply by t instead of multiplying by t minus the center. And then integrating t cubed over another 3 will make that 9. T to the 4th divided by 4, 9 times 4, on an AP test, I would not stop and do 9 times 4. But the finger method, if you know it, 9 times 4 is 36. And then I know I don't mess up. And then the general term also needs to be done. Take everything that's the constant multiple, and then integrating t to the n plus 1 over, or sorry, I wrote minus, there we go, over n plus 1. Then, if I'm going through this very technically, then I plug x in to everything that I see. And when I say everything that I see, I mean every t that I see. And then minus, and then I plug 0 in. But because 0 is the center, everything is 0. So I don't even need to write minus 0, but realize that technically that is going on. So how much work do you have to show? Honestly, you could go straight here if you understand what you are doing. If you look at it and know that you're looking at the center to x, if you're aware that that means I'm just going to integrate what I have and not bother with a plus c. That's going to save a lot of time if you're aware that that's what's going to happen. Just make sure that if you're dealing with a polynomial that isn't centered at 0, that when you do the integration, you do variable minus center. I'll put t, but make sure that you use that and not t if it is a different center. That's important. Okay, that was part B. And let me make sure. First 4 terms and general term. 1, 2, 3, 4. Yes. Okay, then we hit part C. And there are a couple of different ways to work with part C. And I'm going to go ahead and just go through this as an infinite series. And I can show you the different answers you might get. But I'm starting with, in order to find k times f prime of ax, I need to first find the derivative of f of x. Then I can substitute in ax, and then I can multiply by constant k. However, steps 2 and 3 could be done in either order, but the derivative must be taken first. So taking the derivative, and let me make sure that I'm taking the derivative of the correct thing. I need this function. That's f of x. I'm going to erase part of this so that I don't mess up. I'm going to come back and erase this because I know I'm going to look at it and I'm supposed to be differentiating the other function. Get that out of the way. And I'm just taking all that out. But the variable is x. All right. Part C. Derivative of 6, 0. Derivative of negative 2x, negative 2. And then 1/3 times derivative of x squared, 2x. minus 1/9 derivative of x cubed 3x squared and when I'm doing the derivative of the constant multiple, I write it down, and then derivative using the power rule, n x to the n minus 1. So then I'm going to plug a times x in. And right here, plugging it in, I'm just going to get 2a over 3 times x. When I plug it into the x squared, I'm going to get a squared times x squared. And then here I will get a to the n minus 1 times x to the n minus 1. And everything else will stay exactly the same. With multiplying by k, I'm just going to go times k. And put it wherever. Wait, I see a question, but I think that was from a little bit ago. You know, I'll look at that question in a little bit. So with this problem, I was supposed to find that, and then h of x is equal to this series, and I'm supposed to figure out what a and k need to be equal to that series. Although when you look at that, you might recognize it, and it can be beneficial to recognize. And I'll talk about that after I go through it this way. So if these have to be equal, polynomials are only equal if their corresponding coefficients are equal. So corresponding coefficients, and that's actually all I need right there. So 1 has to equal negative 2k, and the coefficient of 1 in front of the x has to be 2a times k divided by 3. And then I can see that k is negative 1/2. And once I know that k is negative 1/2, then I get this, and that winds up being negative 3 for the a. And that was going back to this problem here. And so just to double check the directions, it says the function x satisfies this, a and k are constants, blah, blah, blah. Just find a and k. So there they are. Now, another way you could have done it is if you had read over it and thought about it and planned a little bit, you could have seen, hey, this is e to the x. Let me erase all this. So h of x is equal to e to the x, and you are allowed to say that in free response because you're expected to know these functions. And then look back at this and see what else they told you and go, hey, well, they gave me the function f of x. Is it legitimate to do the differentiation that I know how to do instead of going through the series? And it is, as long as you identify the series that they wanted you to show being equal as long as you show that you understand that this is e to the x. And then they did give you the function for f of x. So from there, you could say, hey, well, f prime of x is 6e to the, shove the baby in, multiply by its derivative. And then plug the ax in. And then multiply by 6. And now you have an equation that this must be equal to e to the x. You don't have a calculator. And I'm going to rewrite this where I can do the work. Negative 12e to the negative ax over 3 is equal to e to the x. So if I'm now going to solve this without a calculator, wait, where'd my k go? Wasn't there a k? Did I mess up? What did I do? I did something.
Instead of multiplying by 6, wouldn't you multiply by k?
Yes. There it is. I accidentally went back to that multiplication by 6 from earlier. So I had gotten negative 2, and now there's a k. Okay, there we go. Oh, nice. Nice, nice, nice. So first of all, the coefficients. There's k. And then the exponents have to be equal. That's negative a. So a is negative 3. That is nifty. So, you know, it just depends on what you see when you read the problem first. And once you start in a direction, usually you don't change midstream, but maybe you decide to change when you're struggling with this and then realize, oh, wait, oh, maybe I could do it this way. But, you know, it's a timed exam, so always be careful. I'm going to stop presenting.